Okay, so we're looking at the three ways of indicating the direction of a vector. So at the beginning, you've learned that a vector has magnitude and direction. So here we have vector v and vector u, and it looks like they have the same magnitude. So they both indicate a push of the same force or a movement in the same velocity in terms of speed, but their directions are different. And as I've stated here, this one is 25 degrees to the right. So from going forward, we rotate to the right 25 degrees. And this angle here is 45 degrees. So I'm just going to show you the three standard ways of indicating those directions. The first one we call a true bearing. And a true bearing considers forward 0 degrees, and the current direction is how far you have to rotate clockwise. How far you have to rotate clockwise from forward to get to wherever it is. So if you look at V, that's 25 degrees to the right. So the true bearing of vector V is 25 degrees, because that's simply 25 degrees to the right. Now, it's quite standard to write it with 3 digits, so if it's a 2-digit number, you just put a 0 in the front. So our true bearing of this vector is 25 degrees. Another way you'll typically see in the book is a quadrant bearing. And a quadrant bearing makes reference from north, south, east, and west. So again, looking at vector v, it's 25 degrees to the right. We would call forward north. So vector v, which is 25 degrees to the right, we would say that its direction is north. We always start with either north or south, and this is clearly more north than it is south. So it is north, and then we must rotate 25 degrees, and then we specify which way we're rotating. So we don't always assume it's clockwise. This 25 degrees is towards the east. This side is west, this side is east. So that is north, 25 degrees east. And finally, there's what we call standard position. I'll just write standard. And standard is what you learned in chapter 1, and it is considering all angles as counterclockwise from the x-axis. So if again we look at vector v, which is 25 degrees to the right, so this here is 25, we would specify the angle as the counterclockwise rotation off of the x-axis. So we call that theta, and I'm going to say that theta is 90 degrees, because it would be a full 90 degrees if we went all the way up here, minus 25, which makes that 65 degrees. So, to recap, the three ways of representing the direction of vector v, which is 25 degrees to the right, we could use a true bearing of 0 to 5 degrees, which means a rotation clockwise from north. We could use a quadrant bearing, and our quadrant bearing is north, 25 degrees rotated towards the east. Or the standard way is to find the angle off the positive x-axis and our rotation counterclockwise. So that's a pretty simple example. Let me do the same three ways of measuring angle except with vector u. So you can see vector u is 45 degrees downward to the left. So I'm going to write that as a true bearing. So again, that's 45 degrees downward and to the left. Now as a true bearing, we start north, and all we have to do is figure out how far we have to rotate clockwise. From here, that's a 180 degree rotation. If we add another 45 to that, that brings us to 225. So our true bearing is 225 degrees. Looking at exactly the same vector, that's 45. Our quadrant bearing we start either north or south, and this one is clearly more south than it is north. So we start off south, and then we must rotate 45 degrees. And which way are we rotating here? Is that east or west? That's towards the west. So it is south 45 degrees west. And we typically put square brackets around there. You would have seen this if you studied physics. We put square brackets around there. We start north or south, then we specify the angle of rotation, and then the direction where we're rotating, either to the west or to the east. Finally, let's write this in standard position. So again, our vector is 45 degrees here. This is vector u. And the standard position is how far we have to rotate counterclockwise from the positive x-axis. From here to here is 180 degrees, and then we must rotate a further 45 degrees. That brings us to 225 degrees. So we would say theta is equal to 225 degrees. Now it's not typical for the standard position angle and the true bearing to be the same. This is the only spot. Because remember, the true bearing starts north, and we would rotate 225 degrees clockwise to get here. Standard position starts along the positive x-axis, and we would rotate 225 degrees counterclockwise also to get to that same position. So those are the three ways of indicating the direction of a vector. A true bearing, which tells us the angle that we must rotate clockwise from north. A quadrant bearing, which tells us how far we must rotate from north or south and specifies whether it's east or west we're rotating towards. And standard. And standard is a counterclockwise rotation from the positive x-axis. But all three of those methods can still indicate the same direction for the same vector.